This is an Advisor tutorial on in-memory data. The Advisor product we'll use is Analyst X, which is our desktop authoring software. Advisor provides a visual discovery and self-service data analysis capability that is powered by an underlying in-memory data model. This in-memory data model powers the entire suite of products to deliver speed-of-thought insights every time. You can load and wrangle data from disparate data sources. Here's a picture of a data model for a dashboard that helps end users find high-value prospects. Each box represents a data table, and each line represents a relationship between the tables. Relationships can be bidirectional, one way, many to one, many to many, one to many, or one to one. In this case, we have an entity table that is our core table, and we have lots of dimension tables, gifts, children, sports, affiliation, employment, and so on, that are centered around the entity table. The entity table was loaded from a SQL Server database, while the giving table, that has one row per gift, was loaded in from a SQL Server data warehouse. And finally, there's a committees table that's loaded from an Excel spreadsheet that's sitting on a server somewhere that is manually maintained. This is one page in the prospect identification dashboard that sits in front of the data model that we just saw. While you can load denormalized or pre-joined or aggregated data into Advisor for analysis, we recommend loading normalized tables to preserve the ability to drill from a high-level summary down to a low-level detail. The table behind this chart here is the gift table. It has one row per gift. By loading multiple normalized data tables separately, you can slice and dice across many-to-many and many-to-one relationships with ease. For example, if we'd like to see and search for our friend Jessie Ains in this table, we can see that Jessie has multiple rows. Actually, Jessie's down here. Jessie has multiple rows where he gave $500 a couple times a year for the last couple years. If we toggle over to the giving history table, we can see that Jessie, Wyatt, and Leon are the only prospects selected. I'm just going to grab Jessie Ains. Now, if I exclude all the other entities here, we can see Jessie's giving by fiscal year all the way back into 1996. What we did to show this view is we took the fiscal year from the giving table and put it up in a bar chart and then sum total commitment. It is to our advantage not to flatten this table before putting it into this chart because we want to preserve the ability to see many-to-one relationships like we do here for Jessie. Let's select our whole population back and ask another set of questions to the dashboard. You don't have to compromise speed for insights in Advisor. Loading these normalized data sets, like the giving table, does not cause a slowdown in performance like it would in a typical data mart or warehouse. You can still query your data at the speed of thought. See, I'm going to ask multiple related questions, which are the equivalent of multiple SQL queries, to my dashboard. None of the performance of the dashboard will be affected. Let's check on who gave a gift anywhere from 2008 to 18 at least once. We'll grab that view and see that we've now gotten down to 37,000 prospects. Now, let's ask another question of these 37,000 prospects. Maybe, which out of these people majored in either engineering or law? Head on to the affiliation page. Actually, we need to go to the degrees page. And let's select engineering and then add in, how about medicine actually? Engineering or medicine. As you can see, we're down from 37,000 down to 2,000 prospects very quickly and no performance is impacted. We can keep asking questions of the dashboard for as long as we like and still not have a performance impact, even if we had millions of rows in the data table. Back to our PowerPoint so we can wrap up our talk on the data model. Now, here's an example of why it's a business advantage to load normalized data tables and keep all of this data in our memory pool. Again, we see the data model from this demo. We have the entity table, and the entity table is linked to the gifts table over entity ID. It's also linked to the degrees table on entity ID, and so on and so forth. That's called a selection link. Another reason you'd want to keep all of your objects within the advisor data model is color links. You can color the data, and the charts will inherit the color from the data. You can pass color from table to table in advisor. For example, you can see some patterns in color here. For these 2,000 people who gave a gift in the last 10 years and who either majored in engineering or medicine, you can see that the engineering school has a higher proportion of very wealthy people than the medicine school does. See that orange subset there? That's another advantage of using color links in advisor and loading all the data into the memory pool. Other advantages of loading the data in memory and then doing transformations in advisor in the end memory data model is that you can copy fields from one table to the next. For example, the C-level job was copied from the employment table on entity ID, and probably a flag was set up as well. The last advantage of an in-memory data model is that you can do roll-ups and create your own calculated tables within that data model with no load on your data warehouse or database. For example, I know that earlier I made a roll-up of right off the giving table that summed up giving by person, and then I copied it to the entity table. This is especially useful when you don't have a lot of IT bandwidth and you need to do some of your data analysis on your own. In summary, loading the data in memory gives you a lot of flexibility when working with many-to-many and many-to-one relationships. You can go from a high-level aggregate to low-level detail very quickly and flexibly. See you next time.